Welcome to my YouTube channel. In this video, we are going to learn the concept of buoyancy and its origin. Now, we have a diagram containing fluid called water. Now, we also have a block that is immersed, totally immersed in the fluid. We notice that at this point, the pressure acting at that point is P1. Then at this point, the pressure acting at this point is called P2. So we have two pressures. It has been established that P2 is greater than P1. So in this case, we notice that the pressure acting at this point is greater than the pressure acting at this point. You also recall that the deeper you go in a fluid, the higher the pressure. So anywhere here, the pressure at any point here is greater than P2 and is also greater than P1. So if that is known, then we can now move on. Then remember that the distance from here to here at point P2 is H2. The distance from this point to this point P1 is called H1. It is also known that the pressure at any point is equal to force all over area, which also implies that force is equal to pressure times area. So, if you now do your mathematics, since we already established that P2 is greater than P1, if you multiply the area in which this pressure is acting on, the same area, because they are made of the same compound or the same block, the area of the same area multiplied to both sides, it will still show that P2 multiplied by A is greater than P1 multiplied by A. Or we can say that since P2 multiplied by A is force, we call it F2, and P1 multiplied by A is called force F1, therefore F2 is greater than what? F1. So if the force 2 minus force 1 acting on a block, the resultant force is greater than the weight of the block, then the block will float. If the resultant force of F2 and F1 is equal to the weight of the block, it will also float. But if the force, the resultant force between F2 and F1 is less than the weight of the block, then the block will sink. So this is the origin and principle of what? Buoyancy, or also known as flotation. The buoyant force is also known as upthrust. So let's quickly look at a problem that employs the idea of buoyancy. A block, a cubical block of wood, 0.1 meter on a side and with density of 550 kilogram per meter cube, floats in a jar of water. Oil with density 750 kg per meter cube is poured on the water until the top of the oil layer is 0.035 meters below the top of the block. So, question A. How deep is the oil layer? So, solution. This is a diagram that depicts what the question is talking about. So, this is a block. We have water occupying these parts. We have oil that is filled up to this point. So, the distance from here to here is X, which is the thickness of the oil in the container. While from here to here is Y, which is not known. The thickness of these parts, that's from the top of the oil layer to this top of the block, is 0.035 meters. Now, it's important for us to note that the pressure at this point is P0. The pressure at this point, this layer interface, is P1, while the pressure just below the block is P2. The density of the oil is given as this, density of water is given as this, and density of the block is given as this. The entire length, because it's cubical, the entire length of the cubical block is L equal to X plus Y plus 0.035. But mind you, our L is already given to be 0.1, which is equal to X plus Y plus 0.035. So X plus Y will now be equal to 0.1 minus 0.035. So the length of the block L equal to x plus y equal to this. Hence, our x plus y will be equal to 0.065 meters. We call this one equation 1, which we'll make use of later. Now, remember that at point P2, which is the pressure at the bottom of the block, minus point P1 is also equal to P2 minus P1 plus P1 minus P0. Now, this expression is also giving us this expression. So the difference between P2 and P1 is the density of water times gravity multiplied by Y, which is the thickness of the block, plus density of oil, gravity times the thickness of the block. If we multiply area A throughout, we get P2 minus P0 A. That's multiplying A to this. We also need to multiply A to this, A to this. That's A will come here, A will come here. A is the area of the block. So we have density of water, GYA, plus density of oil, GXA. So the last expression is called the buoyancy. The last expression is called the buoyancy. P2, P minus P0, A is equal to BF. This is a buoyant force, which is equal to this expression, which was found in the last expression, plus this part also. Now, this buoyant force must be equal to the weight of the block. So, therefore, we now take care of this one and this. We equate this one and this, which is weight of the block is equal to this part plus this part. Now, what is the weight of the block? The mass of the block times G, which is equal to this part plus this part. We can take care of our G cancels out, and we are left with mass of the block, density YA, density of oil XA. So the mass of the block is equal to these expressions. But remember that the mass of the block can also be re-expressed as the density of the block times the volume of the block, which is equal to this expression. Now, our volume of the block is the thickness, length times the area of the block. Now, we now notice that A is common, which can be taken care of, leaving our density of block times the length of the block equal to this expression. Now, the length of the block is 0.1, and the density of the block is also known. Density of water is known, but Y and X are not known. So, since the density of the block is known and the length is known, equal to the density of the water multiplied by the thickness of the Y plus this expression, which is the density of the oil times the thickness of the oil. So if we take care of this, multiply this, we'll get this equal to this. This is equation 2. Now recall that from our equation 1, x plus y is equal to 0.065 meters. So solving simultaneously both equations, we'll get our x equal to 0.04 meters and y equal to 0.025 meters. So in that case, we can now see that the thickness of the oil, which represents x, is 0.04 meters. The thickness of the block that is submerged in the water is 0.025, which is gotten from this. So if you add this entire length, that will give you 0.1 meters, which corresponds to the length of the block. So the problem is solved. That is x equal to 0.04, which is the thickness of the oil. Thank you, and please do subscribe to my YouTube channel, share and like. Thank you.